How do you map the entire human DNA sequence? Is it really possible that William Shakespeare wrote all of the works that bear his name? Can you create an intelligent computer program that can write its own novel music compositions? What do these three real-life questions have in common? Well, answering these questions requires the use of computational thinking, which is a way of thinking that more and more people are using to solve problems each day. So whether you teach math, science, computing, or the humanities, computational thinking can be a powerful addition to your classroom activities. So what is computational thinking?
Computational thinking is an approach to problem solving. So it's taking apart a problem and figuring out how to attack it using what we know about computation. There's four major sort of facets of computational thinking. One is decomposition, breaking something down and figuring out what all the parts are and how you might divide up a task.
And then there's pattern recognition, which is finding similarities and differences between these parts in order to make predictions. Pattern generalization, or abstraction, which is finding the general principles that generate these patterns. And finally, there's algorithm design, which is developing the step-by-step instructions that solve similar problems. People are learning to apply computational thinking to solve problems in many disciplines. When people ask difficult questions, which are more easily solved by computers, or discover insights through analysis of large data sets, they are thinking computationally. Computational thinking is the reason we now have fields like computational biology and computational chemistry. It's also the reason we have new techniques we can use in literature, social studies, and the arts.
So when we start stepping back and looking around us, we see computational thinking everywhere, and it doesn't have to be a scary thing.
Some people confuse computational thinking and computer science, but they're quite distinct. Computer science is an academic discipline involving the study of computation and its application using computers.
Whereas computational thinking is a way we go about attacking problems.
Right, using big picture processes and abstract ways of thinking.
It's something that you could use regardless of whether or not you're a computer scientist or something else. It's a general skill that would benefit you.
Computational thinking increases students' confidence in dealing with ambiguous, complex, or open-ended problems. We believe that all students should learn computational thinking, regardless of subject or age group.
Being able to take a problem, break it down into many different sized pieces, work on each one individually, and eventually bring it all together to solve something, that's a skill that can benefit anyone.
Imagine that you're a journalist and that you want to know what people are saying about an upcoming election. One option is to ask people on the streets about their opinion. Another option is to use a computer program that can analyze social media posts on thousands of web pages in just a few seconds. See, this is an example of the benefit of approaching a problem computationally. So, in the past, if students wanted to see and understand data, they needed to collect the data manually. Now, by developing an algorithm, students benefit from quick results and are able to focus their attention on insights rather than data collection or calculation. By leveraging the strengths of technology, we can focus on our strengths as people, developing insights, analyzing situations, and drawing conclusions. We don't want students to simply use the models that we teach. We want students to be able to create their own models. And to do so, students must find the hidden patterns and insights that can be discovered with computational thinking. Computational thinking is not an additional burden or an extra topic that needs to be taught. Rather, it's an enhancement to your existing curriculum.
So with my students, early on, I just try to use everyday examples to help them understand that it's something that's accessible to them, and then they can start to see how computational thinking does exist in other aspects of their life.
If our students are technology creators, armed with computational skills, they will not only be able to participate and position themselves professionally in a global society, they'll also be able to contribute to society by solving big problems using creativity. So how did we map the human genome? Well, algorithms and computer programs helped us to sequence the millions of base pairs in our DNA. And what about Shakespeare? Turns out computational analyses of the vocabulary, themes, and styles in Shakespeare's works confirmed that he could have indeed written all of the works attributed to him. And that intelligent music-composing computer program? Well, computational thinking was used to find patterns in existing musical compositions and write programs that produced brand new compositions based on those patterns. All of the remaining grand global challenges facing us as humans are problems that require an interdisciplinary approach. By integrating computational thinking skills in all of our subjects, we're preparing students to contribute new solutions to seemingly impossible problems. So yes, many mysteries still remain. For example, what causes gravity? Can we create cures for diseases like cancer? We may not be able to answer these questions today, but perhaps with computational thinking skills, our students will be able to answer these questions in the future.